What causes C++ segfaults to appear only in releases? Imagine running your C++ program and suddenly hitting a crash only in the releases version. It can feel like a puzzle because the debug version runs perfectly. So what makes these crashes show up only when you releases your code? Let's explore the reasons behind this mystery. When you compile your C++ code in debug mode, the compiler adds extra checks, keeps variables alive longer, and keeps the memory layout simple. These features help catch bugs early. But in releases mode, the compiler turns on optimizations that change how the code runs. It might reorder instructions, remove what it sees as unnecessary, or even eliminate variables you think are still there. These changes can expose hidden bugs that never appeared in debug mode. One common cause is uninitialized variables. In debug mode, the compiler often fills uninitialized memory with zeros or known patterns, which can prevent crashes. But in releases mode, those variables might contain random data, leading to invalid memory access. Another factor is memory layout. Debug builds add extra padding and guard bytes around buffers to catch overflows. Releases builds pack memory tightly, so out-of-bounds access can overwrite important data and cause crashes. Timing issues also come into play. Releases builds run faster, which can change how threads interact. Race conditions that don't show up in debug mode might cause segmentation faults in releases mode. Undefined behavior is a big culprit too. For example, dereferencing a pointer after freeing it or relying on unspecified order of operations can behave differently when optimizations are enabled. Sometimes, missing or incorrect compiler flags make a difference. Debug builds often include checks and disable certain optimizations, while releases builds do not. To find these bugs, you can compile with warnings enabled to catch potential issues early. Use debugging symbols in releases builds to help tools like GDB or Valgrind pinpoint the exact line causing the fault. Running your program under these tools can reveal invalid memory reads, use after-free errors, or buffer overflows. Always check that your pointers are valid before using them and initialize all variables properly. Review your threading code for race conditions and test different optimization levels to see which one triggers the crash. Remember, the key is understanding that releases builds optimize aggressively and assume your code is well defined. Bugs caused by undefined behavior can hide in debug mode but explode in releases mode because of these optimizations and memory layout differences. By systematically applying these debugging techniques and tools, you can uncover why your C++ program crashes only in releases mode and fix those bugs once and for all.